for Standard 9. Today I am going to deal about some special terms which are important in kinematics. To understand the kinematics, it is important to know about these terms. So here is the terms: displacement, distance, speed, velocity, acceleration, and rate of change of speed. These terms must be understood in the kinematics for the basic idea of motion. So first of all, I am here discussing about displacement and distance. What is displacement? Surely, displacement is a vector quantity, and the vector quantity have two things. First, it has some value or magnitude, and second, it has direction. So it is denoted by letters with an arrow. Here you can see a body moves along a straight line from A to B. So the displacement from A to B can be written as AB vector, but its magnitude can be given by the length of AB or the path length of AB. Have you got my point? And the direction can be assured by this line, because a single line gives a single direction. A straight line gives the single direction. So the direction must be from this side to this along this line. So that for the direction, we have to go from the line AB. I have already told you how can you denote direction in different ways. So I am not discussing here about the direction, because for your standard there is no need to bother about direction, because you have to study mainly on the motion of straight line. And we already know that in a straight line direction is fixed. So we don't need to add extra information of direction. We only take magnitude and understand all the problems, all the concepts. Have you got my point? You must deal different cases and complex cases in 11th classes where the direction of vector quantities are changed. So here I am dealing with simple cases. So what is displacement? Displacement is a minimum distance or shortest path length or shortest distance between 2 points. Have you got my point? So if anybody wants to go from A to B, he or she can go in many ways. He or she can go along this line, he or she can go along this line, or one can go along this line, one can go along this line, and one can also go along this line. So what would be the smallest path? Can you say? Surely, after observing this path, you can say the smallest distance is always a single straight line from A to B. So the smallest or shortest distance from 2 points is the straight line constructed between A and B. Have you got my point? So displacement is defined as the shortest path length between two positions or two places or 2 points. Have you got my point? It is the definition. So if I have to uh, uh, take the value of displacement, we have to first draw a straight line from that point to that point, because it is in the definition. Because here there is a given that it is the shortest path length between two places. So automatically it is a single straight line, not two straight line or three, or not a curved line, but a single straight line. Have you got my point? From origin to the final destination. Have you got my point? So if I am giving you the various ways of moving from A to B, what will be your answer for the displacement? Can this path 1, be the displacement from A to B? Or can this path be the displacement from A to B? Or can you say this path length may be the displacement from A to B? Have you thought about it? If you choose any of them, you must draw. Why? Because these paths are surely curved line, and the shortest distance between 2 points cannot be curved line. So all the cases here is not correct. Now I am giving you another case, that if you travel along this path, this is a straight line path, but not in a single line. It has different segments of a straight line. Have you got my point? So can you say this path length is the smallest? If you say yes, you must draw. Why? Because the smallest path length must be this, a single straight line. Have you got my point? So don't confuse that if path length is a straight line broken in various segments, then it may be the displacement. No, it may not. But a single straight line gives the concept of displacement, gives the value of displacement from one point to another. Have you got my point? This is the case of displacement. As I already told you, that displacement is a vector quantity because here is a direction along this line, and direction from A to B. Here arrow indicates the direction. But in this case, arrow changes, so its direction it changes after some time. In this also case, direction changes. In this case, direction also changes. But if you take single straight line, direction never changes. If you are in east, you always in east. That's why I have told you that the single straight line gives the idea of single direction. Have you got my point? That's why a vector quantity have a direction, a particular direction. So it may be negative, it may be positive, or it may be zero. I have already discussed about it. What is the difference between vector and a scalar? So here I am giving you example. If you want to go to the point B from A, so you take the step 4 step ahead and then come back and go to the point B. What would be your displacement? So I have already told you it is a single straight line from where you start to where you end. Have you got my point? So your starting point is here and your ending point is here. So your displacement must be this path, arrow towards this. Have you got my point? This is your displacement. So what is the value of your displacement? This is simple. You can count the units: 1 unit, 2 unit, 3 unit, 4 unit. If it is taken in meter, then it is 4 unit. So the magnitude of displacement or value of displacement is 4. But you can see here the direction is opposite. Direction is a westward. So you can say the displacement of this case is minus 4 unit, because if you take eastward as positive and westward negative, so you can take its direction also. So the displacement becomes here, the displacement becomes minus for direction, value, unit may be meter or centimeter, whatever. Have you got my point? So displacement may be negative because of the direction. Have you got my point? So this is your final point and this is your initial point. So you have always draw a straight line from initial to final point. Don't think that you go up here. No, you have to go along the same line. From A you are going here and then you come back along the same line here. I am drawing like this because it may give confusion to you, so I am writing this. Have you got my point? But what is the distance in this case? You can say distance is simply is the total path length you covered in your journey. So you go A to B in this path, whatever it is. It may be curve, it may be straight line, it may be various segments of straight line, maybe. So you have to count all the path length from the initial to final point. So here you have to add this and you have to add this total. This gives you the idea of the distance. So here this is 4 unit and here this is 8 units, so it becomes 12 unit. Whatever the direction it has, it does not depend on direction. It does not bother about direction. It does not have meaning for direction. So distance is a scalar quantity. It is actually the total path length in the journey is known as distance. Have you got my point? Distance cannot be negative because it does not bother about care about direction. So you go east, you go west, you go northeast, it doesn't matter at all. It only count the path length. It only measure the total path length. Have you got my point? So here 8 unit is the distance. So you can think the difference between displacement and distance. I have already told you in the previous lectures that what is the difference between scalar and vector. So you can also differentiate on that ground that what is the difference between displacement and distance. Now, in the next case, I will give you more examples here. Can you find out the displacement in this case? So here you have to start from now, from here, and you have to go in a circular path and stop at here. And the radius of this circular track is 7 centimeters. Means you cover 3/3 part of this circular track. Have you got my point? So what would be the displacement in this case? And what would be the distance you covered in this case? For distance, you can cover, you have to measure the path length, whatever it is. It may be curve, it may be straight line, no matter. So you have to measure this path length up to this. You already know the path length of a circle or circumference of a circle is 2 pi r. So now you can calculate the path length covered by it of third part of this path length. Have you got my point? So you have to calculate it. You can calculate easily. Now for the displacement, you have to only care about the final and initial point, and you have to draw a straight line, a single straight line from the initial to final point. So our initial point is here and final point is here. So you have to draw a single straight line. And the direction would be the direction would be along this line and towards A to B. Have you got my point? So you can now calculate that this is 7, this is also 7, and this is 90. So by Pythagoras you can calculate the value of this line. So you can get the value or magnitude of displacement. But here you don't need to bother about direction, because in your class it is just you have to left it out. Okay. The problem only is given upon the value or magnitude of displacement. Have you got my point? So here AB is the displacement, and so you can calculate the AB as it is a part of right angle triangle, or you know about two sides of the triangle, 7 centimeters, 7 centimeters. You can calculate the other hypotenuse by Sulba-Sutra or Pythagoras theorem. So in this case, you can also find out displacement and distance. How can you find out? As I have told you that you have to draw a straight line from initial to final, because the shortest path length from the 2 points must be a straight line, not the segments of line. Here there are 2 segments of line. It cannot be smallest. So I have to draw a single straight line from A to B. So the direction must be from A to B along this line. But I don't care about direction here. Only I have to find out the value or magnitude of the displacement. So AB is the displacement. You can now find out the diagonal of a square. It is the value of displacement. Have you got my point? So I am giving you a oral problem, Moon's problem or market problem. Moon's problem means let us take an example that if moons revolve around our Earth in about 27 days, then what is the displacement when it revolves around it thrice? Or what is the displacement in 81 days? Can you think about this, about the answer of this question? Now another problem is if you go to the market from home. Now in the market you have to buy vegetables and other groceries and your stationery materials, and after spending 1 hour in the market you then come back to your home. What is the displacement in this case? Can you think it out for yourself? Now I have already told you what is the meaning of distance. It is a scalar quantity and it gives the idea of path length. So it has no direction at all. So it cannot be negative. It may be zero if I am I'm at rest. I am not traveling uh, anymore. So the distance covered is zero. So zero may be possible, but negative cannot be possible because it does not care about direction, in which direction I cover the length. Have you got my point? Its value never less than value of displacement. That's why its value never be the less than a value of displacement. Why? Because displacement is the smallest. By the definition, displacement is the smallest path length in the whole journey from one place to another. That's why by definition it is the smallest. How can the distance be smaller than this? Are you get my point? So distance never be less than the displacement. Yes, displacement may be equal to distance in the case when a body travel in a single straight line. When a body travel in a single straight line from, let us say, from point A to B, then the distance is also the displacement. Yes or no? So for the single straight line or single segment of line, the displacement is same as distance. But the distance never be less than displacement because the displacement is the smallest value from one place to another. So I am giving you a problem here. It is like a stair, and each step is 1 meter in length and 1 meter in height. So a ball is dropped by somebody, and then ball go towards this point like this in a straight line. Okay, so what is the distance traveled by the ball? It is easy. You can say ball covered here 1 meter, covered here 1 meter, and covered here 1 meter. So total distance traveled by the ball is 3 meter. Have you got my? But if I say you, so what is the value of displacement here? So how can you get? Think about it. Now, in the previous cases, you have to find out distances. I have given you problems. So you have to find out distance and displacement by yourself. If you face any difficulty, mail me or comment on my YouTube channel or contact Xiii. Now, the third important term here is velocity and speed. Velocity and speed. So I am giving you some idea about what the velocity means. So you have to grasp it out. You have to understand this term, because if you didn't understand these kind of terms, you cannot solve the problems in kinematics. So think about it, grasp the concept, what it say, what is the meaning of this term. You have to think about it and understand about it. Have you got my point? So, well, what is velocity? Velocity is nothing but a rate. What is rate? Can you say? You go to market and show to a shopkeeper, what is the rate of this pulse? Shopkeeper said 5 rupees per kg? Yes or not? So it means the value of 1 kg must be 5 rupees. Have you got my point? Means this is simply a unitary method. You have to take 1 kg, you have to find out the value of the rupees or the money of 1 kg with respect for some materials. Have you got my point? So here rate is with respect to mass. The unit of mass is kg, kilogram. So here rate means 5 kg per 5 rupees per kg means here rate is taken with respect to kg with respect to mass. Have you got my point? So it is not a very big concept. It is simple. But try to take it in another way. If you take the rate with respect to time, what will happen? Let us say I am traveled 5 meter in 1 second. What is your rate? So by the common sense or by the similarity, you can say my rate is 5 meter per second or 5 meter in 1 second or 5 meter per second. Have you got my point? So can you give the special name for the quantities? You say 5 meter per second. Physicists say yes, you have to define this term because it is very important term in physics. So take another name for it. Have you got my point? So generally in physics, rate is defined with respect to time, not with respect to mass. You take it in your market or in commercial purpose. Have you got my point? So in physics, generally time is taken for the reference for rate. Have you got my point? So any physical quantity is rated with respect to time in physics generally. Then one question is here, of which rate I considered here. Means kiska rate? I have told you rate is defined here with respect to time, not with respect to mass. But of which rate? Whose rate? So if I define a velocity, I have to take rate of change in displacement. Means how much displacement I cover in that interval of time. For example, if I am at 2 meter from my home and after and I travel 2 seconds more and cover and reach at 10 meter from my home. What is the difference between displacement in that case for 2 seconds? It is simply 10 minus 5. It is 5 meter in 2 seconds. But rate means in 1 second. Have you got my point? So in 1 second, I have got my value is that is 5 by 2 or meter by second, means 5 by 2 meter per second. Means my rate is 5 by 2 meter per second. Means in 1 second I travel 5 by 2 meter. Have you got my point? So here I write a symbol. This is delta, which is the letter or alphabet of Greek language. So delta is S means change means difference means subtraction between two displacements. So here I am taking delta as vector. But in your class, direction does not care anymore. So you cannot in general we don't mention the sign vector Are you getting my point? So delta means change or difference or subtraction. So what is the definition of this term, special term in physics, velocity? Velocity means rate of change in displacement with respect to time. You have to define that what kind of rate it is. Have you got my point? So it is a rate which is based on time. In the market, you take the rate which is based on mass of the material. Have you got my point? But here in physics, generally the rate is depend on time. Have you got my point? So velocity is nothing but the rate of change in displacement with respect to time. Now I give you example. If I travel to this point for 5 seconds and the length of this or displacement of it is 2 meter. Now I am travel from this to this and I have taken 25 seconds and its displacement is 10 meter and so on. So what would be the rate by which I moving or you can say bus is moving from bus stop to school? Here it is a straight line, it is in the straight line, so we do not have to bother about this direction. So I am only take the value or magnitude. So I am giving you a answer, it is 0.4 meter per second. So it means the bus traveled 0.4 meter in 1 second. You can think it out yourself and then you can understand the concept. Otherwise if you do not think about it, how can you understand? Think about this, how I am giving you the answer like this. In 1 second it travels 0.4 meter. Why I am saying? How can you solve? This is simply easy. I am giving you some hint that in 5 seconds it travels 2 meter. That's why, or you can say in the whole journey, for whole journey it covers the displacement 10 plus 2 plus 15 from this to this. Have you got my point? And it takes the time interval as 5 plus 25 plus 37.5 seconds. So by unitary method you can find out the rate. What is the change in the displacement? Here change in the displacement, if bus is here then displacement is 0 and the bus is here, displacement is the sum of all the displacement. So the change in displacement is the total displacement or total path length of this straight line. And what is the time interval between these change? That here time is 0 and here is total time. So the time interval is this minus this, means this is the total time. So by unitary method you can say if you divide displacement by and time, then we get rate, because we have to find out for 1 second. So in unitary method we find out for 1. That's why the rate is the division. Rate is the division between two quantities. But if I take the rate with respect to time, then the time must be in the denominator. Have you got my point? So we can get this kind of. Have you got my point? Rate means division because it is given by unitary method for 1. Have you got my point? So by unitary method we can define, we can write it in mathematically that velocity is the rate of change in velocity, means let us say first displacement is let us give you some another example. I give you example so that you can understand thoroughly. Now this is my home and I am here at this place at present. Have you got my? Now I am at rest here. Now I am walking from it along the same straight line for, let us say, 20 seconds, and I traveled 30 meters and reach at this point. So can you say what is my rate with respect to time? Can you say during this journey? Because I travel from this to this, not from this, from this. Have you got my, from this to this? So what is the displacement I covered here? Oh, sorry. If I take you, the displacement from my home here is 40 meter from my home, and the displacement of this point is from my home is 10 meter. If my home is the origin, or my home is the reference frame from which we measure the displacement. Have you got my point? So what would be the displacement of my journey? So displacement must be AB, and this can be given by the final displacement minus initial displacement. Final displacement minus initial displacement. Have you got my point? So the rate, the definition of rate is change in displacement, not displacement. Change in displacement means difference in displacement. So it becomes S2 minus S1. That is 40, or you can say S final minus S initial, means final here and initial here. Displacement final, displacement initial. So it becomes 40 minus 10 meter. It gives 30 meter. Have you got my point? So this is the displacement of my journey. And now this displacement is covered in what time? I have given you this displacement covered in 20 seconds. In 20 seconds, I covered 30 meter displacement. Have you got my point? So by unitary method, you can say in 1 second, I covered 30 by 20 meter displacement, that is 3 by 2 meter displacement, that is 1.5 meter displacement. So if I am asked by somebody, what is your rate of your motion, then I will give the answer as my rate is 1.5 meter per second. That is 1.5 meter per second. This is nothing but velocity. Its name is given by velocity. So this rate has a special name because it is important term in kinematics. So its name is given separately, which is velocity. Have you got my point? So what is the formula can you get? Velocity is equal to, you can say, S2 minus S1 or S final minus S1, that is 30, 30. But you can say 20 second means time from this to this, and time from this to this, and time from this to this. If you subtract, you can get time from this to this, means T2 minus T1. You get T means 20 seconds. So I got T. By definition, we have mathematical formula of velocity. Have you got my point? Now In physics, there is two kind of physical quantity. Means measurement is taken in two ways, average or instantaneous.